All right, so I'm just going to repeat myself. So we just helped a couple people with getting their Section 4 study notes. And I was just about to explain some of the common errors that you might get, especially when it's your first time doing this. So one common error you would get is that git fetch upstream doesn't work. It would probably say like fatal, you don't have access, there's no upstream, something like that. So if you get that error, make sure that you do step 2, that you add an upstream. So if it says fatal, it probably means that there's no upstream, and you can add an upstream by doing this. You can also check if there's an upstream by doing git remote -v, and it should come up that the upstream is my URL. Another thing I had mentioned before I started the recording was that every time you're done making changes on any of your notebooks and before you pull changes from my end, it's a very good practice to do your git add commit and push of your own notes before you do 4, 5, 6. So basically whenever I put up new notes and ask you guys to pull down study notes, I would say do 3, 4, 5, 6. So you're pushing your local changes onto your remote. And then when all of those changes are done, then you can fetch my new changes. Any questions on this? Does anyone else like get any weird error that I didn't really address? One other common thing could be a merge conflict. And a merge conflict would basically come from you not doing this step of your own changes before fetching my changes. So my changes and your changes would conflict. And basically all you have to do is do this first. And if anyone runs into that issue in the future, just let me know and I can help troubleshoot. Any other questions regarding pulling the study notes? All right, I know I had noticed that not everyone has forked the study notes. I can see who has forked it. So if you haven't, I will call you out in your 101s with me. So, all right, before that, no, actually, let's just get into section 4. Section 4 is where stuff gets to get important. It starts to get like it starts to feel like you're doing real data science, in my opinion. It's where we start to introduce Python libraries, which everything we're going to use is in a library. Some of you have asked like, oh no, I feel like I'm still not getting good at coding. Am I going to be able to catch up, as it gets harder? The way I see it, I feel like the level of coding and the level of Python that we're using is going to be pretty much the same level of coding we're going to use at the end of Mod 1. So there's not going to be like harder Python ways to code functions. It's more going to be like, we're going to be introduced to a lot more libraries that help us do things. So the level of coding, I'd say like, it's definitely learning a new language. It's very, very tough. So don't feel like, I think it's very easy to feel like you're falling behind. But in our one-on-ones, I'll help you through that. One more thing for a reminder of you, for those who weren't at my last study group, end of section 3, there are a couple like practice questions that I would like to go through during this week's one-on-ones. So just remember that. If you don't have time to get to that, we will code it from scratch during our one-on-ones and do a little bit of pair programming. Any questions? All right, so to get started, section 4 introduces NumPy and Pandas. This overview I copied from learn.co, but I think it's very useful to just reiterate what this stuff is. So NumPy is the most fundamental package used for scientific computation. There's no better way I could have put this. It's a library that lets you do a lot of mathematical operations that aren't already built into Python. So for example, there's like no square root function built in Python. You can get square root from NumPy. Wow, what are some other math things? Logarithms, if anyone has heard of that word, that's something that you can do using NumPy. And more relevant to us is we'll be using a lot of their functionalities when it comes to arrays. And so arrays, as we're gonna see a little more later, arrays are a specific data type that is built into NumPy. So whenever we wanna use arrays, we have to import NumPy, and we'll talk about that later as well. We're gonna be using arrays a bunch. Arrays are the kind of data that is fed into machine learning models, and arrays also help us to, do things in multiple dimensions, which sounds scary now, but no worries. In Mod 3, we'll get to linear algebra, where we'll talk a little bit more about that. So that's NumPy. It's mostly for like the math stuff. There's also Pandas, and Pandas is how you work with tables in Python. It's this relational data, and so relational data, you can think of this as like, let's say you have an online store, and you want to keep data on like your inventory, what people are buying, what items. So you might have like a table of your inventory, like your items and how many you have in stock. You might have like a transaction table of like, whenever you have someone buy something, you keep track of how many of each thing you buy, and you can they're sort of relational because you'll be able to like connect that data using, maybe you have like user IDs, and if you have more user information, you can do that. Or if you have like item information, for example, if someone buys like if someone buys 2 of item X, you can help keep track of like in your other table of your inventory, how much there is left, things like that. So it's relational in that sense. Pandas is really, really good for data wrangling. So oftentimes when you're going to see that data is never perfectly clean in the way that you want it to be. Pandas is really good for that. It's really good at cleaning. It's really good for standardizing your data. By standardizing, I mean like making sure they're all in the right format. Like, for example, can you imagine like survey data? If you're having like thousands of people fill out a survey, and especially when you have those like open-ended questions, people always answer however what way they want. Like even like the number of different ways to say not applicable, or like NA. You could see people putting like N/A, but like dashes, leave it blank, and you want all those to be the same thing. Something like that is like Pandas is the perfect package to help clean that kind of thing. So this information is pretty much copied from learn.co. So I'm not going to go through all of them, but we're going to go through the functionality of these packages. Before we start, any questions about anything I just said?
So yeah, one quick question. Not to lag behind, which are the lessons that we need to focus the most in this section?
Absolutely. Actually, yeah, let's do that. Let's go into my learn. And let's see what are some good ones to focus on. There are a lot of them that are reading. A lot of these labs are just for reading. I would say the getting started with NumPy and NumPy lab, just so you know, you have an idea of NumPy. The readings are, I feel like you could just like read once and they'll make sense. Pandas, I would say these 4, accessing data and importing data. These four are important. If you want a little bit of a challenge, there is this. I will preface this by saying that these introduce lambdas, which I'm actually going to talk about on Thursday. So if this stuff doesn't really make sense now, feel free to skip over it for now. And a good one to look at is, in terms, if you want to really focus down on something, I would say those 6. Getting started with NumPy through to importing data using Pandas. Yeah, we'll start with those as a foundation. I feel like if you have time to do the rest, you should be able to get through them all. Yeah, these 6 are. All right. Back to section 4. All right, so I'm going to start by talking about NumPy arrays. And the way you would use NumPy arrays, don't worry about this, it looks pretty intense, but whenever you want to use a package or a module, you have to import it. And just by like standard, I don't know when this came about or how it came about, we always import NumPy and we always alias it as NP. So you're gonna always import NumPy as NP. And whenever you want to use something that is inside NP, you do NP dot whatever it is that's built into NP, into NumPy. So therefore, to make a NumPy array, you can just coerce structured data into np.array. An array actually looks very much like a list. So let's take a look. So what I did was I just fed it in a list of 1, 2, 3, 4 and put that into np.array. Let's take a look. All right, so it says, here's a NumPy array, looks just like a list. And it says, you know it's a NumPy array because I printed the type of it. It says numpy.ndArray. So just know that it's another data type and it looks very, very similar to lists. It does everything lists can do and more. And that's what I'm going to get into. And so when you have NumPy arrays and lists, NumPy arrays let you go in more dimensions. NumPy arrays let you look at things in higher dimensions. I'm going to just print this out and then explain what all of these things are. Here I made basically a bunch of arrays. If you're familiar with like higher dimensional math, these words will make sense, but if not, please don't worry about it. You have vectors. So basically a vector is a list of numbers. We'll talk about what it means, what a vector actually means in Mod 3, but for now, don't worry about it. But if it's a one-dimensional thing, it's a vector. And by one-dimensional versus two-dimensional, you can see here that I have nested lists. I have two lists of threes. So here you can see I have 1, 2, 3 in one list and 4, 5, 6 in another list. And anything in 2 dimensions is a matrix. Don't worry too much about this shape, but actually, yeah, the shape of the matrix is kind of important actually for now. It's 2, 3. So it's 2 rows of 3. So you always go outside in when you're talking about the shape of the matrix. This is less important for now, but I think it's good to at least have an idea because we're gonna get to this in Mod 3. But anyways, the opposite, we have 3 lists of 2, and this is 3 of 2. So you see how like that numbering works for shape? And then here's a little more, it's another layer. We actually have 2 lists of 2. You have 2 lists of 2 lists of 2. A little confusing, I know, but you can see here there's 2 groups of like 4 numbers, and each of them is grouped into 2. What this is and what it's used for, not important yet, but this is basically different. This is basically different array types. Anyways, this is because I want to demonstrate what's so good about arrays and what makes it better than lists. And it's the idea of broadcasting. So broadcasting is super powerful. You can mess around with indexing later on, but basically, if you take like the first, anyways, that's something you can do on your own. But what I wanted to get to is broadcasting. Broadcasting happens when you perform operations across arrays with different number of dimensions. For our purposes, this is the only instance that it might matter for now. Basically, NumPy makes duplicates of the lower dimension array as long as the higher dimensional array contains the same shape to execute the operation. That's like a whole lot of mumbo jumbo. I actually took this from my linear algebra lecture, but what it means to say is that here, if I have a scalar 4, and if I have a vector, which I printed 1, 2, 3, 4, 5, 6, I can just simply take vector plus scalar, and that scalar of 4 is broadcasted onto every element in the vector. So that's the idea of broadcasting and why it's better than lists. Because in lists, you would have to do like a for loop or a list comprehension in order to do this. But in NumPy arrays, you can just broadcast and it will automatically broadcast. So that's what broadcasting is. I can just take the vector plus the scalar. It goes from 1, 2, 3, 4, 5, 6, and it just raises every element by 4. It just broadcasts the 4 onto every element. And that's a concept that's very important for NumPy arrays. What I mean by like as long as the higher dimension array contains the same shape, this is an example that kind of, I think, describes it. So you see here I have V1, and V1 is 101. M1 is 3 groups of 2s that go 1, 2, 3, 4, and 5, 6. So broadcasting here will not work because they look at the inner shapes. There's nothing in here that matches this shape, if that makes sense. So I'm gonna give you an example that will work to contrast, but if I wanted to like, let's see, broadcast the vector onto the matrix, that's not going to work because it says could not be broadcast together with these shapes. What would work is if it was like this. If I switch it to instead of 3 groups of 2, it becomes 2 groups of 3. This works. See, so it broadcasts 1, 0, 1 onto both 1, 2, 3 and 4, 5, 6. So you see it becomes like, yeah, I think, yeah, the math makes sense. So that's the idea of broadcasting, and that's what makes NumPy arrays way more powerful than lists. This gets a little intense, and I will give you this exact thing when we get to linear algebra, so don't worry about it for now. In terms of creating arrays, as I demonstrated earlier on, you can just feed in like a nested lists into np.array to create arrays, but you can also use these methods that might be useful in practice. So you can create like an array of all zeros by doing np.zeros and just feeding it in a shape. So for example, let's see, if I do np.zeros and I feed it a shape of like 2 and 3, oops, it needs to be in a list, I think. There we go. It'll just automatically create an array like this. In later cases, and if you go through the later labs, you'll see why this could be important. So similarly, np1 does the same thing. And then I think np full, you have to give it a shape and also give it like the list of numbers you want to put in or something like that. Yeah, that's not important. So as you can see, I don't remember any of these off the top of my head, but the labs explain very clearly how this works. So don't worry too much. I believe it is in this Getting Started with NumPy lab. So highly recommend you go through those ones, because what's more important, not more important, but what has a lot more to learn about is pandas. And I really want to focus on pandas for today. So any questions about NumPy before I move on? Awesome. As usual, please feel free to interrupt me because I could go like on and on. All right, so very similarly to NumPy, we like to alias pandas for some reason into PD. So we always import pandas as PD. Very common at the top of any data science project, you'll see NumPy PD as the first 2 things that people import. This is in a little bit of a different order than the labs go, but I want to talk about getting data in and out of pandas. So I've been asked like, okay, I have data, but like, how do you get your data into your Jupyter notebook? That's a common question I get. So you can't really get your data if you have to have those data files existing somewhere first. So you might have them as CSV files, as Excel files as well. You can put Excel files into pandas. And what you do is you have these functions. You have read CSV. If you have Excel files, it's actually read Excel. And what you do is you just feed in either like a link with CSVs, or you can feed in like your file name. So on a lot of the labs, you'll see that if you actually go into some of the labs, maybe this one. If you go into the labs and you take a look in their GitHub, you'll see that they have CSV files. So they already have this data. It's just not in, that's how you get it into the notebook. So to import your data from these like raw CSV files, which you can see if I click onto it, these raw CSV files, to get them into your notebook, you just have to feed it into the pd.read CSV function. So yeah.
One quick question. So for Excel also it is pd.read CSV?
Nope. So for Excel, there's a pd.read Excel. So literally you can Google pandas read Excel. And it tells you exactly what to do. There's an example of like, see if you want to open your Excel file, you can even tell it which sheet to open, all of that. So the most common data type actually would be CSVs. But if you have your own Excel data and you want to work with it, you can do it like this. So I know that this URL gets me to a data set about cars. So what I'll do is I can just run this cell. Let's see what it looks like. And our data is here. And then we can start playing and cleaning this data. Very often you might see, like, if you wrap it in a print statement, this is the thing that's a little funky about Pandas. If you want to just print it, it doesn't show up in that nice format, that like slightly interactive format that I had earlier. So just know that if you want to like see the Pandas table nicely, you don't want to wrap it in a print statement so that it prints out like that. Or I think there's another function called like pd.display, but don't worry about that. Usually I would just always just type in the variable so that it outputs nicely. So we can read CSVs, and Pandas is great because you can do a bunch of cleaning. So let's say there was a bunch of messy data in here and I already cleaned it up, and we'll talk about cleaning more on Thursday. But I've cleaned it up and all that. Pandas is really great because you can save those cleaned files as CSVs, so you don't have to redo it. So what we have here is literally the function toCSV, and I put index equals to false because I'll talk more about indexes another time, but don't worry about that. I'm just making up this file name. So let's look at my like page here. I don't have any CSV files here. I just run this cell, and immediately, it may take a while, but it should save a CSV file here. There we go. So you can see that it automatically created a CSV file from the data here. So in the future, when you're doing your data cleaning, I just highly recommend that you save your CSV file so you have a clean version, so you don't have to like go through your cleaning process over and over again.
So it's like we just need to mention car, whatever the file, that the data frame that you have, to the dot, it's a dot, right?
Yep, dot to CSV. So this is the variable that has the data frame. And then I just do a to CSV, feed in a string of the file name, and then it'll save to a CSV. All right. So we have that. We have getting CSVs from something that already, getting data frames from data that already exists in some sort of like structured file type. But you can also turn other data types that we know into pandas. You can also do this with arrays. But here I just want to demonstrate turning lists and dictionaries into pandas data frames. So to start, I'm going to turn this dictionary into a data frame. So you see this dictionary, I have the words of the numbers 1, 2, 3, 4, 5 as keys, and 1, 2, 3, 4, 5 pointing to an index. So pd.dataframe, you can do from dictionary, and there's so many different ways that you can do this. Like it doesn't have to be from dictionary. It can be from like, I think it can even do like from HTML. It can come from, we'll get to those data types later. But one of the options is you can take it from a dictionary, feed it in a dictionary, tell them which way what axis we're gonna put this data in. So we can either have 1, 2, 3, 4, 5 as the column names or as the index names, if that makes sense. When I output this, maybe it'll make a little more sense. So here I told it that I want my keys to be the index. So index is always the leftmost column. So there we can see I have 1, 2, 3, 4, 5 pointing to 1, 2, 3, 4, 5, and it's already in a little table of its own. So if I had it as column names, so I think it would just be like columns, it would be pivoted. It would be flipped around where like the column names would be 1, 2, 3, 4, 5, and the values would be 1, 2, 3, 4, 5. So we can do that. And then let's say, so by default, it creates the column name of 0 because it just doesn't know what it is. So we can assign column names by just feeding it in a list to numbers.column. So my data frame is called numbers. Numbers.columns. Actually, let's take a look at what numbers.columns is first. Let's comment this out. Numbers.columns right now is a range that starts at 0 and stops at 1. So because it was an automatically generated column name, this is what the column is. So we can reassign this to something else. So in this case, I want to just call this column numerical. And you do that by just assigning it. It has to be a list because usually there are multiple columns. But anyways, this is just a demonstration. And when I do that, it updates the column name to say numerical. That's pretty neat. Next, I also have this list of the numbers in Spanish. And let's say I just wanted to make a new column in a data frame and call it Spanish. It kind of has a very similar syntax to a dictionary, where I can just create a new column by calling data frame column name equals to whatever values. So over here, you see here I only have the numerical column. Here, all I have to do is do this line here, where it is data frame, which is always DF for short, column name equals to values. That's the format of how you add columns to a data frame. Let's output that, and you see that automatically adds this column, and it has the Spanish names now. Any questions?
Yeah, so if we want to do multiple columns, and if we just separate it by comma and then add strings, will it add all the columns?
Yep, that'll work. That'll work. Well, you have to make sure that things to make sure is that like the length of your list here has to be the same length as the number of rows that already exist. So that's something that you have to take note of. Also, if you want to do multiple columns, you have to make sure that they are nested lists so that it knows like where to separate the two sets of data.
Oh.
If that makes sense. All right. We'll play around with that during when you guys are working on the labs. And if anyone has any like specific questions relating to like something that they go through, we'll talk about that. So don't worry about this. I just wanted to load this data set so that we can play around with some of the pandas functions that are introduced in this section. So there is this this module that just has a bunch of built-in data sets, and they have this wine data set, and we're just going to assign it to data, and we're going to load it into a data frame. And you'll see that the typical variable name for a data frame is df. So let's take a look at df. And this is just, I guess, a bunch of data about wine. So we have like, I guess, alcohol percentage and all these, I don't know, chemical makeup of wine. So cool. This is our data frame that we're going to play with for the rest of this. When it comes to data frames, and actually you'll realize with a lot of other data types as well, there are attributes and there are methods. And so that's the difference. Is I know some of you have asked me like, how do I know when to put like the parentheses and when I don't need the parentheses? Usually when it's an attribute, which is something that's like, I like to sort of think of it as like characteristics of a data frame that like they don't have to calculate anything new. It's an attribute. And so attributes don't end with the parentheses. Some very common ones are like index, columns, D types, and shape. And I'm just going to demonstrate what these do. So df is that data frame that we have up here, this wine data frame. If we do .index, it basically gives us the index. And in a data frame, the index is just this column, this leftmost column. df.index, you can see that it's a range. So it's 0 to 178. You can always coerce it to a list if you want to like really see what's in there. And there we go. df.index sometimes could be useful because sometimes in other data sets, the index isn't just a range. Sometimes the index could be like a user ID or like a transaction ID, for example. So that's a very useful attribute. Next, there's df.columns that I did this a little earlier, but you can probably guess is the column names. Forgot the S. So df.columns is a useful one. If you have a lot of columns, it'll just print out all the names of your columns. So you can just take a look at what columns you have in your data set because that is important. So you can see here, we have, all right, alcohol content, ash, and alkalinity of ash. I don't know chemical makeup of wine that well, but maybe someone does, this makes sense. Color intensity, hue, proline, all of these. So this is basically, it's a very easy way to explore what's in your data set.
So is that just a list, a typical list? Like
yeah,
that you can do
it's not exactly, the data type is not exactly a list. Pandas kind of has its own like data types. So if we were to take a look at the type of this, it's its own data type, see? So it's a Pandas index type, but similarly to with the index, we can always coerce it into a list. And that looks more like a list. So if you remember earlier, without the list coercion, it comes like this with this like index object. All of these, even though it doesn't look like it, you can still iterate through them. So there are some specific functions that only work on list types, but for the most part, you can still iterate through these and you'll be fine. Good question. There's D types. And so it just shows you what kind of data types are in your table. D types. So here you can see that, okay, they're all numbers. They're all floats. That's usually a good sign. And finally, one that I actually use a lot is df.shape. df.shape tells you how many rows and how many columns. So this data frame has 178 rows and 13 columns. So those are just some of the mostly used data frame attributes. Any questions about attributes? So oftentimes you're given like a giant CSV file and you can't really tell all these things just by like, looking at it. Sometimes you can have like 50, 60 columns and like tens of thousands of rows. I've worked with a data set in like a Jupyter Notebook that was like 6 million rows. And so something like this, doing like a dot shape or like a dot columns, dot index, that can really be helpful. Cool. So those are attributes. Now we have methods. To start, there's dot head and dot tail. So df.head and dot tail basically let you display the start or the end of your data frame. Very commonly, you use it to like preview your data. So let's say you do a bit of cleaning and you just want to check that your cleaning worked, you would do df.head. So df.head by default gives you the first 5. So you can see here, first 5 rows of the data frame. If you want to see more, you can feed it in a number. df.head 10, so you get 10 rows. Exactly the same way, but the bottom of the data frame, you have df.tail. So this takes a 10 from the bottom. And again, the default is 5. So these are always useful to like, just check your data. Another useful method is df.info. Now here you can see info sort of gives you like a summary table. Like here you can see like, okay, these are all the columns and this is what exists. This is really cool because I really make use of this, like the non-null count, because sometimes you have a lot of missing data in your tables, and this is very helpful to see like, whether there is any missing data in any columns. And so one, like to put in context, sometimes I can see, all right, there's 178 entries, but what if there's only like 5 non-null objects? Then I know that, okay, in like flavonoids, that data maybe might not be very useful. And here also it tells you the data type. So it's just like a one-stop shop to see what's going on. Very similar but different information is df.describe. df.describe, you can see here for each of the columns. So these are all the same columns that existed in our data frame. They give you summary statistics. So I think at the end of section 3, we talked about summary statistics. I didn't really talk about it too much in the study group, but they tell you how many rows there are, what is the average value, standard deviation, smallest value, minimum, maximum, and also like the percentiles, the interquartiles and the median values. So usually when you're given like a huge data set to start with and you don't know where to start, this is literally what I do. I do like .head, .info, .describe, just so I can see like, get an idea of what's going on a very like high level scale. Finally, I really like doing isNA.sum. And so if you see here, there are actually 2 methods going on at the same time. So you can totally stack methods. So I like to do df is NA. Let's see what df is NA before the dot sum does. df dot is NA basically looks at every single value to check if it is a null value or not. So I think because we saw in like the dot info that there were no null values, all of these actually come up to false, which is a good thing usually. And so if there were any null values, if I were to sum it up, and this is sort of like how something that's pretty cool, that it will sum everything up on a column basis. And hopefully when I run this, it'll make sense. It'll say that, okay, for every column, what is the sum of all the values? And in Python, true has a value of 1 and false has a value of 0. So that becomes extremely helpful for us because this kind of summarizes what's going on here. So here I have all falses. If I had any null value, if I do a dot sum on it, there would be numbers that aren't 0. That makes sense. That's a very helpful tool to see, like, okay, if I have missing values, maybe I want to like replace missing values with something so that I can still use the data. That's a really useful, this is a really useful method that I use a lot.
This is covering the entire database.
The entire data frame.
Data frame, okay.
Yeah, so you can stack methods, as I mentioned. You can do dot sum, and you can do dot sum again, actually, and it'll tell you the sum of all the null values. So the first dot sum sums up all the rows, and the second dot sum with the sum of everything else. So if that number happens to be more helpful for you, you can do the dot sum twice. Any questions about methods? There's also like dot mean, dot count. There's so many methods in Pandas. I cannot go through all of them, which is why I really highly recommend that you go through those labs on Learn. But these are the main ones that are going to be like the building blocks of when you begin an analysis. Cool. So there is that, and then there's also selecting data. And so let's take a look at df again. Let's say I wanted to get a specific subset of data. There are 2 ways to subset your data using indexes. So there's an iloc and a loc. Loc is short for locate. iloc is something that I like to use because it lets you look through a data frame based on its index. So it's kind of similar as like indexing through a list, but now you can actually specify like the rows and the columns. So if I want to, let's say, get, let's say I want to get like, let's see a random number. Let's say I want to get like the rows 50 to 100 of the rows, and I want like columns 2 through 6. That's the format I would do. So if I have this and I run that, you'll see that I have rows 50 to 99 because similar to a list, it'll stop at the number before. And then in terms of columns, it goes by the order of the columns that it appears in. So this would have been the 3rd, 4th, 5th, and 6th column. Cool, so that's how iloc uses. Loc, so iloc, the I stands for index. When you have regular loc, here it'll be a little less, it'll make a little less, actually no, it'll still work. So that's most commonly used by like using your index and your column names. So here the index, we're lucky that it's numbers as well, but if you had like specific IDs, you can feed it in like a list of IDs. And then here, I can feed it in, let's say, magnesium. There you go. So this is the information for magnesium. And I believe I can, I'm pretty sure I can give it like a list of different columns. I think ash was one of them. And if I do that, I have both magnesium and ash. So if I did an iloc, this wouldn't work because iloc only takes in numbers, whereas loc takes in whatever the actual values are for the column names and the index numbers, for the index values, like whatever are like the bolded on the leftmost column are. Cool.
Would loc still work for numbers?
I think so. let's take a look. So if I had like this, so it has to match, right? See, so it doesn't look for, first it doesn't do slice indexing. But yeah, so this will work with an iLook, but not a look, because I think it looks up the column name values. Question. Typically I use a combination of loc and iLoc, depending on like whether I want to get like a specific slice of the data, or if I want like, if I only know my column names, not like what index number they are. So I use a combination of both. So that's loc and iLoc. What's more important, I think we're going to talk about, is filtering a data frame. I'm going to preface this by saying there is a .filter function that came out after I learned about pandas. Like, it's a pretty new function, but I think it's good to know the original way to filter data frame, because I think it's a little more intuitive, because the filter uses a lot of weird symbols. You can feel free to look it up. I think one of the labs does talk about it, but I think most people now still use the old filtering method, but definitely like check out .filter if you'd like. So let's see, let's look at our data frame as a whole first. And let's say I want to filter and only get the wines that have flavonoids above 1. So how you can do that is you call the data frame, and it's sort of like calling a dictionary, because you always use the square braces, the square brackets. But we think about the condition. The condition we're looking for is that we want flavonoids. So we want df flavonoids is greater than or equal to 1. And that takes a subset of the data frame that has flavonoids over 1. Does that make sense? I feel like a lot of people are tripped up by like the double df, but if we like space it out a little bit more, you're really just like subsetting your original data frame with whatever, with this condition where flavonoids is greater than or equal to 1. And you always have to say that it is, you always have to say that it's the flavonoids that comes out of this data frame, if that makes sense. Since we're on this topic of like indexing using columns, to pull out specific columns, and I guess to pull out specific columns, there are 2 ways to do it. One, you can do it like a dictionary and do like magnesium, like that, and it'll pull out all the values of magnesium. But if your column names don't have spaces in them, you can also do df dot magnesium, and you don't even have to put it into quotes. Magnesium. And that gives you the exact same thing. So it's really up to you. I find this a little easier just so I don't have to put it in like the quotes, and also I don't have to do the brackets. But it works both ways. You can do this as well. And this does that. There are other ways you can filter. You can filter by, you can give it multiple conditions. I think I can do this. And let's see, df.ash is, let's see, greater than, let's do 2.5. I think this will work. Never mind. There's something about the syntax that you have to do like .any or .all. That I will get back to you guys on. Again, I don't know off the top of my head. But usually when you want to filter, you can do it like one at a time. You can do it like this, and then you can stack filters as well. So let's say you want to get like other ways to filter. Let's say you have this where like, okay, all the flavonoids are over 1. And let's say the only important data that I want to look at right now is like the ash data. So to do that, I can like look at the ash column of the wines that have flavonoids over 1. That's also something that's very useful. If you want to look at multiple columns, let me take this out and take a look at what other columns is. Alkalinity of ash. All right, so let's say I want to look at ash and alkalinity of ash. I'm going to copy this so I don't have to type it out. a lot of people assume that you can do this, and they'll throw you an error where like, okay, they can't find this key. Well, because there are no keys, or by key they mean column name, that is ash comma alkalinity of ash. So when you see this, and this is a very common error, all you have to do is know that it takes in a list of lists. I know it seems a little bit redundant, but that's how it recognizes it. And that's how you get multiple columns to show up. So this is particularly useful when you want to like plot specific variables. So let's say you just want to look at ash and the alkalinity of ash. You would just take out these specific columns and then put them in your whatever your plotting functions are. And plotting we'll talk about in section 6 as well. So that is, I think, all the basics of pandas. Any other questions so far?
With regards to it abbreviates the list when it's long. Is there a way to...
Can you say that again? Sorry.
Oh, it seemed to like it has like a ... after the 4th or 5th row.
Yeah.
Is there a way to manipulate that or change that?
Yeah, there is a hold on. I think it's Pandas Display. Yeah, display max rows and display max columns. I think all you have to do is do like a pd.set option. Yeah. So this is literally what I do for almost every other thing. I look up Stack Overflow, and you can totally do that as well. Copy this over, and if I do this, so I do a pandas.set option display.max rows. I don't even think I need this 500 number. Oops. I guess I do need the 500 number. Let's see. Let's take a look at pd.set option. Let's see, this is their documentation. So let's see what it needs. Yeah, so I guess you have to feed it in a number of rows. So I guess in this case, let's just give it 999. And now I'll display all the rows. Some pros and cons to doing this is that if you're displaying a lot of rows, sometimes it can make your computer really lag out. So I think that's a big reason why a lot of us do like df.hid just to like preview the data. But I totally get that like sometimes it's better to just see everything. Just like if there's any like 10-digit number, it'll immediately stick out as you're scrolling. But as I said, like I've worked with data sets that are like in the tens of thousands or in the millions. You don't want to have display max rows because it's gonna lag out your computer a lot. But yeah, that was a good question on like how to get rid of that. You can do the same thing for columns, because I think if we go up and take a look here, does it show all the columns? It does, but I think past a certain number, by default, it doesn't show all the columns. Good question. Anything else? All right, because I want to give a little preview of what's coming on Thursday. So, highly recommend that you take a look at, there's this lesson on Learn about data privacy and ethics in this section. It's just a good read. If you don't have time, I guess I wouldn't worry about it, but it's a good thing to just keep in mind as you're working with data that could come from anywhere. And also this, Kaggle and the Ames housing data set. If you haven't heard about Kaggle, Kaggle's a really good data source because it just has a bunch of data sets that people have found, and it's open sourced. And it could be a source of where you get your data for your future projects. So I highly recommend this. That really just tells you how to set up a Kaggle account. So just do that during your spare time or something. So to preview next section, we're gonna talk about lambdas again. I know we've had some like fun with lambdas. And so lambdas, we're gonna use that with series and data frames on Thursday. And I'm gonna show you how to do that. We're gonna talk about like very basic data cleaning techniques. And if you noticed here, there's like a lab on data visualization with pandas. The reason why I'm not going through data visualizations in pandas is that pandas does have some built-in plotting functions. And if you scroll through the lab, you can see that you can plot all of these sorts of plots. But these plots are actually made with matplotlib. And we're going to talk about matplotlib in section 6 anyways. However, the plotting library that is built into, so basically the plotting library that's built into Pandas calls on matplotlib functions. So anything that we can do with matplotlib, this will do the same thing, but matplotlib you can customize it a lot better. But I have this resource here, I think it's this one. Yeah, the .plot function. If you're going through that lab and things don't make sense, you can definitely refer back to here. These are all of the arguments in .plot. So you can see, first of all, what's going to be on the x-axis, what's going to be on y-axis. You just give it your column names. What kind of things to plot. There are all these different kinds of plots. There's like line graphs, bar graphs, histograms, box plots. Those they talk about here as well. Scatter plots is a very common one. What else? Yeah, so there's that. Yeah. At the end of section 4, there is a mini project. I will say it takes up quite a bit of time. I'd say like, if you want to work on it, allocate roughly 2+ hours to do it. So I totally understand if you don't get through that one, but that's a pretty good one to at least look at. It's over here, EDA with Pandas using the Ames housing dataset. EDA is a huge thing in data science. It stands for exploratory data analysis. And it's basically what you're going to be doing for your first project. So if you want to get an idea of what you'll be doing for your first project, take a look at this lab. Maybe you don't have to like do the entire project. Maybe like do a little bit. You can totally like look at the solution and see how their approach is, just to get an idea of how you would explore data that's given to you. So there's this like CSV file that they provided. So yeah, you can just like take a look and see how people start to explore data. I mentioned this after the plot function because here in their prompts, they ask you to plot your data onto graphs. But I think like with the methods that we've gone through today, you can get a pretty good sense of what's going on. And then if you want to figure out .plot, which you totally can, and I think it's pretty easy to figure out. If you have questions, please Slack me. That's how that works there. Any questions?
So will this be the first step of the project that we need to really understand and for the section 1?
Yeah.
If we go to this particular part, right, and understand this properly, we should be able to do the project very comfortably.
Yeah. So I'd say there are 2 mini projects. Let me double check. So section 4 has a mini project, and so does section 5. Those 2 mini projects are going to be very, very similar to the kinds of processes that you're going to be doing for the end of mod project. So I really recommend that if you have like extra time to at least like take a look at the solutions and how they're doing it. I think that's a really good, like, just, getting exposure of how people do data cleaning in Pandas. And then, yeah, I think those 2 are the main bits that are going to really put together our mod final project. Any other questions? All right, to wrap up, I will say, if you haven't cloned this repo down, if you haven't forked and cloned this repo down, please do, because that's where all of these notes exist. Also, that's where section 3 notebook, which has the question that I want you guys to answer for me during our one-on-ones, the end of last study group, these 2 questions, I would like to go through them during our one-on-ones. So please do that. And if there's no other questions, I'd say have a good night, you guys. Bye, everyone.
Bye-bye.